we're going to have a look at how to solve stuff with a modulus function in it. So, if we have a look at this, we want to find the points where the graphs of y equals modulus x squared minus 5x minus 4, and modulus minus 2, and y equals 12 minus 2x meet. Let's start off by just sketching this very roughly so that we think how many solutions we're expecting. This graph will look something like this. Okay, so it's a quadratic which has been translated down 1, and then it's a quadratic which has a modulus applied, and then it's been translated down 2, sorry. If you want to check where the y-intercept should be, you can just plug it in very quickly. X is 0, 0, 0, minus 4. Modulus of that would be 4, so we know that the y-intercept is where the modulus has taken effect, which is why I drew the turning point before x equals 0, and then we subtract 2. So that y-intercept would be at 4. Okay, and then we can just sketch the line 12 minus 2x. So that is going to be some line like that. Something like that, it's close enough. That may not actually be on the x-axis, but it illustrates the point that we're expecting up to 1, 2, 3, 4 solutions. Maybe my sketch isn't very good and the line should be above and we're only expecting 2, but the algebra will tell us that as we work through. Okay, so how to solve this? Well, like any time you find in intersections, you set the two equal to each other. You're basically substituting that y in there. So we get 12 minus 2x is equal to modulus x squared Okay, first of all we're going to look at finding these two intersections. Now that was where we would have just had the regular parabola if the modulus hadn't taken effect. Our graph would have just looked like that. So we'll assume first of all that this modulus function has had no effect, and we'll just pretend that it's not there, because there are intersections where that modulus has had no effect. And we'll see that this simplifies to 12 minus 2x, x squared minus 5x minus 6. I can then just solve this as a quadratic, bring all my x's onto one side, or all my terms onto one side. Factors of 18 which are 3 apart. So I can see that x is 6 or minus 3. I can then substitute those into this equation because it's much easier to find my y values. So I'm going to get 12 minus 12, y is equal to 0 in this case. And when x is minus 3, I'm going to get 12 plus 6 is 18. Okay, so you can see my sketch wasn't very good. That one being positioned at minus 3, 18 wasn't a bad guess. But in fact, this one should have intersected on the origin. But like we said, it's only a sketch to help me visualize how many solutions I'm trying to find. I didn't expect it to be perfectly accurate. Okay, so that's one set of points that we've found. Now let's find the other pair. So in this section, that's my reflected portion of the graph. At that point, the modulus has had an effect. What's in here was negative and it's turned it positive. So in that case, I'm looking for 12 minus 2x equals, and because it's reflected this in the x-axis, I've basically taken the negative of this function. So I change all of the signs in it. That will become a plus 4. Notice I'm not changing all of the signs on this side of the equation though, only those within the modulus. The minus 2 will not be affected by the modulus. Okay, I can now tidy this up, bring everything onto this side to make my quadratic positive, just like in AS, it's just good practice. Minus 7x, and then that was going to be plus 2 plus 10 equals 0, and that factorises. So we can see that x is 2 or 5, meaning that y will be, again plugging it into this equation just because it's simpler, 12 minus 4 is 8, and 12 minus 10 is 2. Again, my sketch wasn't perfectly accurate, but it illustrated the correct number of solutions. I should probably then, because it did ask me for the points, just list all of the points that I have. 6, 0, minus 3, 18, 2, 8, and 5, 2. Remove any ambiguity of the 6 pairing with the 0, the minus 3 with the 18, and so on. And you can see that we can solve an equation where we've got a modulus in it by first of all assuming that the modulus takes effect, and then assuming that that the modulus does not take any effect, and then assuming that it does take an effect. A quick sketch just helps you see that you are looking for the correct number of solutions. And we're done.